Hey, and welcome gurus to this lesson, Azure Load Balancer. I'm Chase, one of your Azure training architects here at A Cloud Guru, a Pluralsight company. And it's in this lesson that we're going to start off by describing what Azure Load Balancer is. We're then going to take a look at some of the internal or external use cases for those types of load balancers using Azure Load Balancer. We'll then compare this idea of basic versus standard SKUs and the features that are provided by each SKU for Azure Load Balancer. We'll talk about the Azure Load Balancer rule types that exist, and then we'll wrap up this lesson with some key takeaways. So to get started, Azure Load Balancer is our Layer 4 networking solution for distributing traffic to backend compute resources like virtual machines or virtual machine scale sets. So whenever we have our virtual networks, and say we have resources like a virtual machine in them inside of a subnet, traditionally, we would have just this resource and it's serving traffic from a client. But let's say we want to scale this out and have high availability for our solution, so we have multiple virtual machines with the same solution. We need a way to be able to provide access to these resources and distribute that traffic evenly. And this is where Azure Load Balancer comes in. We access Azure Load Balancer in an external Azure Load Balancing solution with a public IP address, and the client is able to then request traffic from that Azure Load Balancer, and that Azure Load Balancer is able to distribute that traffic to those resources that exist in our backend pool, be they virtual machines or virtual machine scale sets. And Azure Load Balancer also supports availability zone specific deployments. So if we want to deploy into AZ1, AZ2, AZ3 for our Azure Load Balancer, it also supports internal and external load balancing. Obviously, in this example, we have an external Azure Load Balancer, but we could also use an internal Azure Load Balancer for distributing traffic privately across resources. And Azure Load Balancer allows us to have regional or global load balancing deployments. So an Azure Load Balancer that is specific to providing that load balancing for a regional deployment or a global deployment for if we have cross-region deployments. And we'll get more into that as we move further into this section. But for now, just understand that we can deploy Azure Load Balancer on a regional basis or a global basis, and there's more that goes into that. Now, also with Azure Load Balancer, we have the concept of SKUs. We have basic and standard SKU, and each of these provides different features for Azure Load Balancer. So this is different from internal and external. This is actually the SKU that determines the features that are available to our Azure Load Balancer. And using Azure Load Balancer, obviously we can control the inbound and outbound traffic using DNAT or SNAT rules that are available for us. We also have health probes, and these health probes are what are going to determine whether or not the instances or the compute resources running inside of our backend pool are healthy and ready to serve traffic. Now again, this is our layer 4 load balancer, and the health probe itself can check via TCP, HTTP, or HTTPS, but the load balancer itself is layer 4, so it's TCP and UDP traffic only. Now, for our Azure Load Balancer, to differentiate between internal and external use cases, let's look at our virtual network here. And in our virtual network, we have a subnet with virtual machines, and this set of virtual machines may have an external load balancer that is associated with a public IP address. And this is so that whenever clients are accessing from the internet, wherever they may be, our public IP of our external load balancer, we can distribute this traffic to those resources in that backend pool. And a common use case for this are web server virtual machines or virtual machine scale sets, something that's serving up a web application. And behind that, we're going to need a database layer. And this is where our internal load balancer comes in. We may have VMs or VM scale sets in this database layer that have that internal load balancer in front of it, and those resources in the backend pool of our web server layer are going to need to access that database. So we can have them reach out to the internal load balancer and its private IP config, and it will balance that traffic to those resources in the backend of our database layer behind that internal load balancer. So the differences really here between internal and external are with our external, we're balancing traffic from places like the internet. And with our internal, we're balancing private traffic. Now, at this point, what we're going to talk about here is our basic versus our standard SKU. And this is different because this is the SKU. These are the features that are available depending on what SKU we select for our Azure Load Balancer. For our basic SKU Azure Load Balancers, we have support for VMs in an availability set, so they have to be in the same availability set, or virtual machine scale sets. Our basic SKU also supports up to 300 instances in the backend pool at a time, and they're open by default because they use a basic SKU public IP address. And this means in order to secure them, we're going to have to use something like a network security group. Now, our basic SKU Azure Load Balancers also provide TCP and HTTP for our health probe, doing that health checking in the backend pool. And typically, we use basic SKU for non-production workloads. Now, for our standard SKU, we have VMs and or VM scale sets in a single virtual network, and we have support for up to 1,000 instances in that backend pool. The standard SKU uses a standard SKU public IP, so it's secure by default. And in order to open up that traffic, we will have to use network security groups because, again, it's secured by default. For our standard SKUs, we also have something known as HA ports, and these HA ports are used to open up all ports for load balancing to those resources in our backend pool. And a common use case for this is whenever we have network virtual appliances, we want to be able to balance all ports to all of those network virtual appliances so that we can allow traffic to be highly available and serve the requests that are coming in through that standard load balancer. And with standard load balancer, we also have support for not just regional, but global Azure load balancing deployments. And our health probe can use TCP, HTTP, and HTTPS as well. And again, this is commonly used for our production workloads where we have our SLAs that we have to meet. And in this case, it provides a 99.99% SLA of uptime. Now that we know the differences and the features between the SKUs of Azure Load Balancer, let's actually talk about how Azure Load Balancer controls the traffic using its various rule types. First off, we have our inbound and outbound NAT rules, and those are those rules that map a source IP to a destination IP and port, and then translate that to another IP and port somewhere else. For example, that traffic coming in from the internet to our public IP of our Azure Load Balancer on a specific port, and then NATing that traffic from public to private, and then sending it to a private resource in the backend using a private IP import. We can do things like administration over SSH and RDP using these DNAT rules. Then we have our load balancing rules, and these are those rules that are actually balancing to those resources in our backend pool. It takes our front-end IP configuration, port and protocol, and it says, send this to a backend pool over port and protocol. This is our 5-tuple hash here, and it balances traffic between those resources in our backend pool behind that load balancer to provide high availability to our solution for a specific port, such as port 80 for HTTP traffic or 443 for HTTPS. And then we have our HA port rules. These HA port rules are our any-to-any ports that balance traffic. They work like our load balancing rules, but they take any-to-any port from the front end and send it to the backend pool. And this is so that we can have highly available load balancing on any port for those resources in our backend pool. Now that we've covered all of this for Azure Load Balancer, let's make our way into some key takeaways from this lesson. Why would we want to choose Azure Load Balancer is the question that I would ask you for trying to understand Azure Load Balancer. Well, the reason is because we distribute layer 4 traffic evenly using Azure Load Balancer, and we can do this on a regional or global load balancing solution so that we can have high availability across either an entire region or globally across multiple regions. So we can see from this that we would use Azure Load Balancer for layer 4 traffic when we're trying to balance traffic regionally or globally. Now, we would also use Azure Load Balancer for this layer 4 load balancing for resources like virtual machines and virtual machine scale sets, which are supported by Azure Load Balancer. If we had an Azure App Service, we might not use Azure Load Balancer because it doesn't support that compute type. We might use something like Azure Application Gateway. Now, with Azure Load Balancer, for balancing traffic in the resources in our backend pool, we also have a health probe that is going to provide that health checking for those resources to see if they are healthy and ready to service requests that are coming in through the Azure Load Balancer. So this provides high availability to our solution, and this is why we might choose Azure Load Balancer for load balancing between VMs and VM scale sets. With Azure Load Balancer, we also have two types of load balancing that we talked about. We have the internal load balancing for balancing in the private IP address space, and then external load balancing for balancing those requests that are coming from places like the internet in, say, for example, a web application. And then with Azure Load Balancer, we have two SKUs that are notable for this course, Basic and Standard SKU. And the difference here is that Basic and Standard provide different features. The easy way to remember it is that Basic is for non-production testing type workloads, and then Standard is going to be for those workloads that are production, and it provides an SLA of 99.99% and also supports HA ports, which brings us into talking about the types of rules that we talked about in this lesson. We have those inbound and outbound NAT rules. We have those load balancing rules, and those balance traffic to resources in our backend pool over ports like port 80. And then we have our HA port rules, and that is a rule type in which we are opening up all ports for load balancing so that we can provide high availability for our load balancing solution. And the important thing to remember about HA port rules are that we can only use that with our standard SKU Azure Load Balancers, more specifically, our internal Azure Load Balancers. All right, gurus, that is all of the key takeaways for this lesson. Thanks so much for joining me in this lesson, and I look forward to seeing you in the next lesson.